Hi, friends. Thanks for coming back. This is the last exam that I'm going to be working on. After this, I'm going to just start working on topical review questions. All of this stuff can be found right here, NK Infinity. Again, if you have not tried these problems on your own, go to this website, admire my looks and how bald I am and how shiny the light is off my head. Click on review. And right here are the exams. So if you want the one we're working on right now, go down here to practice test number 5. Just click on it, and there it is. You can print it all you want. It is yours to keep and to love and to cherish. When you're done with that, come over here. Check out, see how you did with them answers. If you didn't do very well with the answers, I think there's a problem with one of those answers, by the way. Then see, now you should be watching the video. Now you're like, okay, maybe Mr. Krause can help me. There's spiral reviews. Each of these has about 8 Common Core types of questions. And down here, we've got essential skill training that I will be eventually making videos for you or doing some live something with it. All right, let's get off. So anyway, that's that. Let's go. We're doing part 2s, part 3s, and parts 4s. I just love algebra. Come on, there we go. That's the end of that one. Okay, let's get going. Algebraically determine the values of x that satisfy this equation. So if you haven't done this before, do this. But let me just tell you, let me just give you a hint. This is equal to y, and this is equal to y. So these two things are equal to each other. So negative 2x plus 1 equals negative 2x squared plus 3x plus 1. Now, because my x squared is negative, they're going to come to, it's all going to come to this side. So 2x squared minus 3x minus 5x, equals 0. Because the minus, those will just cancel, right? Oh, that's interesting. All right, no worries. And then I just take out, what do I have here? I have a GCF, right? I can take out a GCF of x, and I'm left with 2x minus 5 equals 0. Okay, then my two answers are x equals 0 and x equals, okay, if you set this equal to 0, you get 5 halves. Now, you know what stupid, silly kids do? They stop at that and they don't find the y values, except I was just making silly. Don't call me stupid. Stupid. I'm not calling you stupid. I'm like saying dumb things because I make stupid mistakes too. But in this case, it just said find the values of x. So I found the values of x. There are the values of x. You should check them. How could I check them in this case? Well, what you should do in this case is take, I forgot what the numbers were, 0. Well, if you plug 0 in for this, you're going to get 1 out. If you plug 0 in for this, you're going to get 1 out because that's going to go away, that's going to go away, and just leaves you 1. So 0 is pretty easy. But let's try this 5 halves. 5 divided by 2, control var x. And then you type in the left side, negative 2x plus 1. Boom, negative 4. Then you type in the next one, negative 2x squared plus 3x plus 1. And look at that, negative 4, and that means that y is negative 4. And I solved it. All right, done with that one. The poll of 200 students are shown in the table below. It says gender preferred music are independent of each other. Okay, first things first. Probably want to get totals. I wouldn't work on something that didn't have totals. So I'm going to total this sucker up. Let's see, 54 and 52 is 106. 36, 76 and 20 would be 96. What was that, 94? Oh, and then those add up to 200. Well, that's good. 90, 65, and 5 and 45. 45 and 65 make 110 plus 90. Okay, so make sure everything adds up to 200. It says 200. All right, we got that in there. So independent. We have a couple tests for independence. The probability of A is equal to the probability of A given B. If that's true, they're independent. Or the probability of B is equal to the probability of B given A. Independent. So it wanted to know if the probability of if rap, gender, and preferred music style are independent of each other. So let's try the probability of female. The probability of being female is 106 over 200. Now, I don't know what that is at a decimal, so I'm going to grab my calculator. 106 divided by 200. 0.53. That's the probability of being female. Now, what's the probability of female given rap? I just picked female and rap. I could have picked any of them. What's the probability of female given rap? Now remember, if we're doing this, this is my new universe. So the only thing I'm allowed to look at is this. It's as if none of this exists. You can't see this. Can't see this. Can't see this. Go away. Go away. Keeps popping back up. Stop. Popping back up. That's like magic. Anyway, that's the only thing that we can see. So if my new universe is rap, then my denominator is going to be 65. And what's the probability of being female and rap? 25 over 65. Now, I don't know what that is, but I'm going to guess it's not the same thing. 25 divided by 60. I am having a devil of a time pressing button. 65.38. So since the probability of female does, and I should probably write this out. Since the probability, anytime they say justify or explain, you need math and you need some words. Since the probability of female does not equal the probability of female given rap, the two events are not independent. Now you could have picked anything. You could have picked male and you could have picked male and country. You could have picked, you know what's funny is Miss Newman did this answer key and she picked female and rap too. You can use any one of these at all. You could show that the probability of techno does not equal the probability of techno given male, or the probability of techno does not equal the probability of techno given female. Anything. If they're independent, they're going to be equal. So you have a lot of choices on that one. Alrighty then, let's get going. Let's see what we got here. Radicals. So what we have here is the square root of x minus 4 equals x over 4. So our problem is we got this weird thing alone, but we got to get rid of it by squaring this. And if I square that, I also have to square that side. So if I square that side, I get x minus 4 equals x squared over 16. Now, this 16 is problematic, so let's get rid of it. We're going to multiply this side by 16, and we're going to multiply this side by 16. Now, if you don't like that, I can just cross multiply. It's the same thing. I end up getting x squared equals 16 times x minus 4. Or x squared equals 16x minus 64. So, oops, not ready to factor just yet. So I get x squared minus 16x plus 64 equals 0. Factor this. Oh my God, that's a perfect square trinomial. X minus 8. X minus 8. It appears that x equals 8 is the only solution. But you have to check it. You know, sub in 8. 8 minus 4. Does that equal 8 over 4? Well, square root of 8 minus 4. 8 minus 4 is 4. The square root of 4 is 2. 8 over 4 is 2. So it does check out. Or you can use your calculator. All right, let's move on. That wasn't a bad one. And then this one. What? What? Huh? What? So when you look at this one, I know you're in an algebra class, and I know you're like, oh my God, what am I going to do? I don't even know. Let me see if I can solve for X. You can't. You can't solve for X. You can't solve for Y. You can't do any of that stuff. So I still want to know what they equal each other. So using my TI Inspire calculator, I found the points of intersection to be, oh, how about this? Found the points of intersection by graphing both and using analyze graph intersection. You must tell the grader what you're going to do. I'm going to use my graphing calculator utility to find the points of intersection. And then we got to go do it. Let's do it. Let's do it. Try not to type these in inappropriately. Let's type them in perfectly. Control division 2 over 9 x cubed. Get out of cube mode. Anytime you're in anything other than squared mode, you're in weird mode. Oops. Control the, what is the what? Control Z. Ah! What just happened? Wait, cancel. Oh, son of a so and so and such and such. Control division. You can scrub through this. Fast forward 2 over 9. I know what happened. X cubed. Get out of cube mode. I forgot the plus sign, so it immediately thought we were going to go into division. Control division. 8 over 9. X squared. Squared mode's fine. Minus 16 over 3. 13 minus 16. Oops. I would always write things out as fractions. You got the option. It takes a little bit over time, but I was always writing them out as fractions like this. X. And then plus 2. Whew, man, that was a pain in the neck. And then I'm going to graph this thing, tab, negative. Now, absolute values are right here next to the 9. Check it out, right here next to the 9, that little crazy button. You're either going to use this one, the book, or menu 90% of the time. Click on this, and absolute value bars are right here. Oh, come on, tab, negative. Absolute value bars, 0.7x plus 5. You know, make sure you look at your graphs and see, hey, is that exactly what I have? Is that exactly what was said? Yeah. So now I want to find these 2 points of intersection. So I go into menu. You told the grader you're going to do this. Analyze graph, intersection, click, click. Now you see how these are rounded to the tens place? That's kind of problematic. They shouldn't really be rounded that early. So I'm going to see if I can get them a little bit better. Settings, document settings, float. It's on float. Menu, let's try to do that again. Analyze graph, intersection, click, click. Well, that's a big problem. Attributes. Oh, I can change it to more. So I'll tell you what I did. I right-clicked on it. I don't know if you can do this. You should be able to. Maybe click and hold. Right-click on it, choose attributes. Oh, I've got it. Right-click, choose attributes. Okay, let's try that again. Right-click, choose attributes, and I'm going to go 3 decimals. Right-click, attributes. Oh, man, it changed it back. Anyway, it's going to round it for you. Right-click, attributes. There you go. So it's rounding it to hundreds place anyway. So I'm going to write down what my two answers are. My two answers appear to be negative 5.17, negative 5.17, comma, 1.38. Then, I lost that one. Menu, analyze graph, intersection, click, click. 1.75, 3.75, 1.75, 3.77. And, oh, wait a second, there's another one. Analyze graph, intersection, click, click, there it is. Negative 1.13. 4.21. 3 points of intersection. But I had to tell him I was using my calculator. What? Algebraically prove that the difference of the squares of any two consecutive integers is an odd integer. Wow. That's a brutal little question. Well, let's say my integers, say let x equal first int. Then my next consecutive integer would be x plus 1 equals my second. I feel like I'm back in algebra, integer. And it said, prove that the difference of two squares of any consecutive odd integers is odd. Well, the square of these, the sum of the squares is x squared plus, we're minus. So we probably should take the larger one. This is going to be the larger one, and we'll subtract off this one. So x squared, x plus 1 squared minus x squared equals. Now, how the heck do I make sure something is odd? Well, isn't 2x, no matter what, even? No matter what, 2x is going to be even. So in order to make an odd number, I'll just add 1. That, my friends, was tough. Double distribute, I get x squared plus x plus 1 minus, plus 2x. Plus 1 minus x squared, does that equal 2x plus 1? This cancels with this. I end up with 2x plus 1 equals 2x plus 1. Now, if you were able to set this up, then that was easy. If you were not able to set this up, whoo, man, that was a doozy. Rewrite the expression blah, blah, blah as the product of 4 linear factors. Say what? Let's see. What am I going to do here? Well, let's see. Here's something odd for you. Check this out. Let's say this thing was x. Let's call it m. So what I have here is m squared minus 5m minus 6. So I'm going to say m is equal to 4x squared minus or plus 5x. That's what m is going to be equal to. M is this. So I end up with m squared minus 5m minus 6. Well, this thing factors pretty easily, doesn't it? This is m minus 6, m plus 1. Right? Well, what is m? Plug m back in. What I end up with is 4x squared plus 5x minus 6 times 4x squared plus 5. This should be 5x. X plus 1. Because this was just that thing I called m, right? All right. Well, if that's the product of 2, but now I want a product of 4, that means probably each of these is factorable. 2x, I'm going to guess 2x and x. Let's go with 3 and 2. That's not going to work. Six and 1's not going to work. How about 4x? Let's try 4x. 4x and x. If I called this 2 and I called this 3, yeah, there we go. That's 8, and that's 3. And I want positive and negative. So those are done. Now let me factor this sucker. This one's a little bit easier. This one's going to be, no, this one's also going to be 4x and x plus 1 and plus 1. Man, baby, that's the answer. The answer key is wrong. Now, I'm going to check my answer to see if I'm right. So I'm gonna put it on the calculator, but I'm going to pause it for a minute. Get out of this. So I'm going to pause it, and then as soon as I come back, I'll have both of these graphed. So, gotta pause. Pause. So here's what I did. I graphed this one. This is that crazy one, and I did that in blue. There's the crazy one in blue. And then I pressed tab, and I graphed this one, 4x minus 3, x plus 2. Now, if I did this correctly, this graph should just trace right over this blue one, but be in red. So watch it carefully. Click. See? So I know that I got it right. Now, I know the answer key's wrong, so I'm going to have to fix that. I'm not sure what Miss Newman's did. She went a little crazy on that one. So maybe, no, wait, maybe she is right. 4x minus 3, x plus 2, 4x plus 1. Oh, she's got it right. I think this originally was wrong. But it's right now, kids. There you go. That was a tough one. That was a tough page. That was a brutal page. Let's just be honest. Let's call it. That is brutal. All right, kids. So here's the dealio, kiddios. Here's the dealio. Yes, this test is not pretty. This test is going to test your resolve. I believe we got these ones off released questions from New York State. And they wanted to release them to let you know, kids, you got your work cut out for you. You got to try things. The good thing about mathematics, keep trying things. You got 3 hours. Just keep trying things. The worst you can do is quit. So what are we going to do here? All right. We want to figure out what y is equal to. Okay? So see how this is a root? If I was to rewrite this, this piece as a rational exponent, I would write it as x to the 8 thirds. Because remember, roots are in the denominator. Now the denominator is a exponent raised to an exponent. So this becomes x to the 4 thirds. Whenever you have exponents raised to exponents, you just simply multiply the exponent. So that's where the 4 thirds comes from. Now when you have two bases that are the same and you're dividing, if you were multiplying x squared times x to the 5th, you would add the exponents and get x to the 7th. But when you divide, you subtract the exponents. So this becomes x to the 8 thirds minus 4 thirds. Well, 8 thirds minus 4 thirds is 4 thirds. So this becomes x to the 4 thirds equals x to the y. So y must equal 4 thirds. Now that wasn't a really bad question, but you had to remember some properties of exponents. Flashcards could help with that. All right, last question like this. Oh my goodness. All right. No problem. We just got some double distributing to do. Key thing to remember is I squared is equal to -1. It's going to come up in this problem guaranteed. So I get 20 minus 15i plus 8yi minus 6yi squared. Now I'm going to clean this up. 20 minus 15i plus 8yi plus 6y. Because remember, this is really just -1, so it makes that negative. Now, I want you to be on the alert for something. I'm going to highlight it and bold it, and then I'm going to draw some red arrows to it. You see that minus? That minus is going to take this problem from an easy problem to a problem most kids would only get a 2 on, or 1 on instead of 2 on. That's the first piece. It's minus this second piece. Now, people are just going to ignore that little tiny nonchalant. Minuses are awful. Awful. You hear me? Scared you. I scared you. Just be careful. Minuses are going to be the bane of your existence. They're going to mess with you every single time because they change signs. They make things so much difficult. You know what makes things easy? No, never mind. Let's start to double distributing. 20 minus 15i minus, are these the exact same things almost? Minus 8yi plus 6yi squared. I should have done that above. Really, the only thing to clean up is this is now a negative. So now we're going to distribute that negative. So we get 20 minus 15i plus 8yi plus 6y. Now we're going to distribute the negative. This is the part that separates the students from the non-students. So I get negative 20 plus 15i plus 8yi plus 6y, just plus 6y. So let's see what goes. 20, negative 20. Negative 15i, positive 15i. So I end up with 16yi plus 12y. You got to be kidding me. All right, so let's see if my calculator can help me out with this problem. I think it can. Check this out. This is the be-all, end-all of coolness. All right, it's not really. So let me just get a fresh graph here. I'm going to store any number, 2.56, and I'm going to store that into y. And I'm going to look down for a second. So let's go parentheses. 5 plus 2 times y times I, parenthesis, parenthesis. 4 minus 3i, 4 minus 3i, parenthesis, minus, parenthesis. 5 minus 2y times I. Don't just use an I button. And then 4 minus 3i. 4 minus 3i. Enter. What? Oh, gosh. All right, your calculator. Document settings. Approximate auto. Oh, okay. Yeah, that's right. That's all right. Okay, I'll take that. Now type in what we came up with. We came up with 16yi. Something's not right. Why do I have an S here? Oh, because of this stupid S up here. What the heck was I doing? It's 2. There we go. That's much better. There we go. That's our answer. Now we're going to type in our answer. Our answer was 16y times I plus 6y. Wait. Plus 12y. Enter. Woo! Look at that. They match. See how they match right here? That matches this. And because they match, I know I got the right answer. I come over here, star it, and be happy as heck. Minuses, kids. Minuses are what are going to crush you. All right. I'm going to take a little break. Take my dog for a walk, and I'll be back. You won't even know I'm gone. By the time you come back, I'll be gone. I might be sweating. All right. Catch you all on the flip side. Well, I kind of lied. I had to go out to a school and fill out some paperwork. So I'm back. I didn't take a walk, no sweating. And I've yet to read this question. So let's see if I can get this right. After sitting at the refrigerator, after sitting out of the refrigerator for a while, turkey at room temperature, a turkey at room temperature should be placed in an oven. So I guess the turkey's at room temperature. Placed in an oven at 8 a.m., so this is the start time. And the oven's at 325 degrees. Newton's law of heat explains that the temperature of the turkey will increase proportionally to the difference between the temperature, blah, 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 blah. The temperature surrounding the object is TA. I'm going to guess TA is the 325. Because if you put it in an oven, that's the amount that's around the thing. The initial temperature of the object, well, that's 68 degrees. The time in hours. Well, that's just time. The temperature of the object after T hours, so that's our final time, and the decay constant, which we don't know either. So let's see what we got. T is the temperature after T hours. The turkey reaches a temperature of approximately 100 degrees Fahrenheit after 2 hours. Find K. Oh, okay. So 100 is equal to, TA was 325, plus TO, that was our initial temperature of 68 degrees, minus TA, that's 325 again, right? 325 again. Times E to the negative K times 2. Holy crap. All right, so let's get that. So what we got to do, our goal is to isolate the weird thing. This is our weird thing right here. We got to isolate this thing. So we got a couple things we got to do first. First thing we're going to do is subtract this over. Subtract 320. I don't know what I was just typing in. Subtract 325. And I'm going to show all the steps so I try not to make any mistakes. Negative 225 is equal to, let's do 68 times. I don't want to do that a million times. Could you imagine if you showed somebody what your calculator looked like when you did all this? And be looking at, what did you do? You're crazy. All right, what do I got? 68 minus 325. Let's figure out what that is. Negative 257. So where did my pen go? So negative 257 e to the negative 2k. So now we're going to divide by negative 257. So 225 divided by 257. All right, we'll just leave it at that. 225 divided by 257. There's no reason to get the decimal equivalent of it. It's going to be some obnoxious decimal, right? So let's leave it as 257. Boom. Is equal e to the negative 2k. All right, so now here comes the magic. We have an exponential function. It is an exponential with the base e. In order to solve an exponential with base e, we must use logs. Any exponentials, you use logs. But with base e, we're going to use natural logs. So we're going to start with the word natural log. Now the base is right here, e. I could put an e here, but you'll notice when we come over to the calculator and I go control log, there's no place to put an e because it is understood to be there. But just to get things where they go, log base e is of this. Remember, these two things are going to switch sides, of 225 over 257 is equal to negative 2k. Now just divide by negative 2, divide by negative 2, and I'll get my answer. So the natural log of 225 divided by 257, enter, divided by negative 2, and I'll put a period so we actually get the answer. And it's 0.06648, so K is equal to 0.06648766487. Round to the nearest thousands. Let me highlight that thousands place. And since the number next to it is a 4, we will just leave it. So K equals 0.066. Yes. Determine the Fahrenheit temperature of turkey to the nearest degree at 3 p.m. Well, the first thing I got to do is figure out what time we start this thing. We started at 8 a.m. 8 to 12 is 4, 4 plus 3. So really my time, first thing I got to do is figure out my time is 7 hours. Now, what represents the final temperature? The final temperature is the T. So all I really got to do is figure out what T is. This is going to be easy. T is equal to 325 plus, now wasn't this negative 257? I mean, I already did that math. There's no reason to do that again. That's that 68 minus 325. E to the negative 0.066 times 7. And all these are numbers, so I just got to type them in. So let's get that going. 325 plus parentheses negative 257 times E raised to the point, oops, did I put negative? There is a negative, right? Yep. Negative 0.066 times 7. Temperature is going to be 163.08. So 163.08. I always like to write down decimals. 425. And round it to the nearest degree. Okay, so temperature is going to be equal to 163 degrees. There you go. Man, that was fun. You know, that looked really bad, but it wasn't that bad. It wasn't that bad. All right, kids, keep working. Let's keep working. All right, this is kind of an interesting question. 72 students are randomly divided into two equally sized groups. Each member of the first group, group 1, is to meet with a tutor after school twice a week. So group 1 is the tutor. Group 2 is given an online subscription. So this is online. They can access for a maximum of 2 hours each week. Students in both groups are given the same test during the year. A summary of the two groups' final grades are given below. All right, so group 1 had an average of 80.16. Group 2 had an average of 83.8. Calculate the mean difference of the group 1 minus group 2, and explain the meaning of this content. So, the mean difference. Is equal to 80.16 minus 83.8, which is equal to negative 3. I got it written down somewhere, 64. Now, what does this mean? So, the average difference of negative 3.64 indicates that those that met with the tutor had, these are final grades, had a mean final grade that was 3.64% below those with the online subscription. All right. So a simulation was conducted in which the students' grades were randomized 500 times. The results are shown below. So this is a randomization of 500 times. 500 times is a lot of time. And notice that it looks like we have a mean average of 0. When we just randomize the kids' grades randomly, now by taking out you're taking out the students' grades and you randomize them 500 times and you randomize them 500 times and you look at them, their mean average grades was about 0. But when you factor in whether or not they got the tutor or not, things change slightly. So here's what's going on. What they did was, I want to make sure I explain. I got to look at my notes. I want to make sure I explain this one to you right. I want to make sure I go through all the process. What they did was they randomized the grades, and they randomized them again, and they randomized the game. So if, let's just start writing this out. If the difference was due to just chance, then we should expect to see a difference of 3.64, or in this case, negative 3.64, a lot of times. So in other words, if we just took all these kids' grades, ignored the fact that they got a treatment of the online tutor, or ignored the fact that they got the treatment of the personal tutor, we just ignored that, we just randomized their grades over and over and over again. If it was just by chance, then we should see a difference of negative 3.64 a lot of times. However, if we look at the graph of the simulation, we see that a difference of negative 3.64 occurs in only, well, how many? Where is negative 3.64? Here's negative 3. Here's negative 3.5. So here's negative 3.64. It only occurs in these little bit. How many is that? That's 5, and let's go with half of that. So 5 and maybe 7. So 12 times out of 700. I don't even know what that is. 12 divided by 700. That's about, what, 2% of the time. So because, however, this occurs in only, or in approximately 2% of the time, which leads us to infer that the difference of negative 3.64 must have to do with the different learning treatments. Yeah, that's it. So basically here's what's going on. We found out, we looked at this. This is what happened in our group. Our group said, here's the two groups. Here's the group that got the online tutor and the group that got the personal tutor. There was a 3.64% difference. On average, those that did the personal tutor scored 3.64% below the others. Now what they did was they took all the kids' grades and they randomized them and got a difference. 0. And you'll see that it's mostly centered at 0, right? You take all the grades, randomize 0. Take all the grades, randomize 0. Take all the grades, randomize 0. But when you don't randomize them and you look at just what their actual grades were, online versus this, we found there was a difference of negative 6.4 times. Now, if that was going to happen, if it would happen, negative 6.4, then we should see that negative 6.4 points or percentage points should happen over and over again. And it only happened in about 2%. Remember, the cutoff really is generally about 5%. I think less than 5% is that cutoff for whether or not you can say it could happen by chance. So since it only happened at 2%, it must have to do with the treatments rather than the actual just by chance. All right, that's that one. So can you see this comment from this guy, Gaming, SRA Gaming? That's what he says. He says, thanks, bald guy. You're cutting me deep, kid. That hurts. I'm follically challenged. I wish I could have Goldilocks. You're making me mad. Just kidding. Anyway, let's get started. What is this? Algebraically determine all zeros of z of x. What is this? Z of 2 is 35. Z of negative 5 is 0. Okay, wait a second. Now check this one out. They just gave us a 0 right there. Because using the remainder theorem, we know that x equals negative 5 is a root or a 0. That means if I take this and plug it in, I should get 0 out. Now, why is that important? Well, that's important because I should be able to figure out b by doing that. So the first thing I'm going to do is figure out what b is. I don't know what this is for. I'll figure out that in a minute. So 6 times negative 5 cubed plus b times negative 5 squared minus 52 times negative 5 plus 15. Now notice I'm putting in everything in parentheses. So I'm going to grab my calculator right now real quick. And I'm going to do 6 parentheses negative 5. I hate doing this. Let's do this. Negative 5 control var x. Now I showed what I was doing, but now I'm going to type it in. 6x cubed to get out of cube mode. Now I'm not going to put the squared thing in, so minus 52x. So minus 52x plus 15. And I get negative 475. So negative 475. Oh, and this should equal 0, right? Because if it's a root or a 0, this should be equal to 0. So negative 475 plus 25b equals 0. Bring the 475 over. 25b equals 475. Divide by 25. I get b equals 19. So now I know 6x cubed plus 19x squared minus 52x plus 15 is my polynomial. Now I know where I don't know, why did they tell us about z equals 2? I still don't understand that. I don't know if that's just to throw you off. So let's do this. We're going to divide this by x plus 5. Remember, because if x minus 5 is my root, x plus 5. If x equals negative 5 is my root, x plus 5 is my factor. So I'm going to multiply this by 6x cubed squared. And 6x squared times both of these. So that gives me 6x cubed plus 30x squared. I'm going to subtract. And I'll get negative 11x squared minus 52x plus 15. Then I'm going to multiply by negative 11x. So negative 11x times both of those is negative 11x squared minus 55x. Subtract. This gives me 3x plus 15 plus 3. 3 times x is 3x. 3 times 5 is 15. Subtract. Now, if you don't get 0 here, we got other issues. So now I know I've got this polynomial, 6x squared minus 11x plus 3. I'm going to factor this thing. I could just go menu 331, huh? What do you think? Menu, algebra, polytools, and finding the roots. It's a second degree polynomial, and my answers are 6, negative 11, 6, negative 11, and 3. So my answers are 1/3 and 3/2. So x equals 1/3 and x equals 3/2. So if I bring this 3 out front, this makes 3x minus 1. If I bring this 2 out front, that gives me 2x minus 3. So these are my other factors. So what is it saying? We got to find what? Find all the zeros of this thing. Okay, so the answer then, my final answer should be negative 5, 1/3, and 3/2. And I still don't know why they gave us z of 2 equals 35. I have no idea. Wasn't necessary. All right. All right, here we go. We got 2 standardized tests that were given. We got one that was given in April and one that was given in May. The April version has a mean score of 480 and a standard deviation of 24, while the May score has a mean score of 510 and a standard deviation of 20. Assume the scores are normally distributed. Joanne took the April version of the score and scored between 510 and 540. What is the probability to the nearest 10 thousandths that a test paper selected at random from April version scored in that same interval? Okay, so Joanne scored between 510 and 540. So you need to show some kind of understanding of what's going on. So the first thing I'm going to do is draw a picture. Try to draw a nice, accurate, normal distribution curve. I'll label it properly with my mean of 480 and my standard deviation of 24. Now this is April. Now we want to know between 510 and 540. So 510's got to be somewhere around here. And 540 maybe up here somewhere. Not really sure exactly where they are, but I want to know the probability that if I select a score at random, that it falls in that window. Well, you really should explain some z-scores. So z is equal to 510 minus 480 over 24. And z equals 540 minus 480 over 24. You should come up with some z-scores for me. So let's see, 510 minus 480, that's 30 over 24. So 30 divided by 24 is 1.25 standard deviations. And 540, that's 60. Well, that's just going to be 2.5 then, right? That'll just be 2.5. Now, you can't really use z-scores because for some reason the state just doesn't want you to use z-tables. They want you to use calculators. So we're going to use TI Inspire. You got to tell me what you use. TI Inspire. Normal CDF. And we're going to use 510. 510. 540. 480 and 24. Now remember, this is min, max, mu, and standard deviation. So I'm just going to tell them that I used the calculator. Used TI Inspire. Then I'm going to go over to my calculator. Menu 552. There it is, normal CDF. Now in this case, I want to use 510, 540, 480, and 24. And I'll click OK. and it's 0.0994. Round to the nearest 10 thousandths. That's 4 decimal places. So the first thing I'm going to do is write it down. So this is equal to, so really what I should probably write down is the probability that that 1.25 is less than or equal to z is less than or equal to 2.5 is equal to 0.09944. 44. There it is, 0.0994. All right. Maria took the May version. In what interval must Maria score to claim she scored as well as Joanne did? So, she basically needs the same z-scores as Joanne. So we don't know what it is, but so in this particular, this is a great problem because this is a way to get you to have to use z-scores without using your calculator. We got to come up with the same stuff for Maria. So Maria has to do the same thing. Let's see what Maria's got to do. Maria's z average is 510. And we want to know what z-score we need for here and what z-score we need for here to achieve the same thing. So this z-score has to be 1.25 and this z-score has to be 2.5 because if you do that, you'll have 0.0994 here in the middle. So 1.25 is equal to x minus 510 over, now what's the standard deviation here? That's the thing we got to write down. We didn't use that. 20, standard deviation of 20. So if I take 1.25 and multiply it by 20, you get 25. So 25 is equal to x minus 510. Add 510 to both sides, so she needs, the low end she needs to get is 535. Now we're going to do the same thing, but we're going to do it for the high end. 2.5 is equal to x minus 510 over 20. And that gives me what? 50, right? 2.5 times 20. Multiply by 20, you actually get 50, is equal to x minus 510. Subtract 510 or add 510 and you get 560. So Maria must score between 510 and 560 points. Why does she have 590? Oh, what? She's got 590 written down here, and then she's got 540 written down here. Okay, which is it? We're going to add 510. Oh, man. She's got all kinds of weird stuff going on. All right, so the answer key is wrong. This is right. I'll fix the answer key in just a minute. So the answer key is apparently wrong. I'm going to fix that. So every time you see something like this, you know you're going to do a half-life formula. Somewhere in there, it's got to be half-life. I haven't even read the question. There it is. Such that every 63 years, the mass decreases by half. So for a sample of, so we have 100 grams of this thing. Write a function that will give the remaining sample after amount of time. So let's call our function, I don't know, we always use a of t. A of t will be the amount remaining. And t will equal the time in years. Now, a of t is equal to, now half-life formulas are almost always done the same way. By the way, this would be the same thing if they did doubling, tripling, quadrupling, whatever. Half-lives just always have the same kind of format. You start out with, what are we going to start with? It's a half-life, and everybody struggles with the exponent. If it did a half-life every year, so if it was cut in half every year, I would just put t here. If every 2 years, I would divide by 2, because it would have to divide by 63. Now, this denominator is always going to be the time it takes for half-life. All right, so we've described our variables. We've defined our variables over here. We got our formula. There it is. Scientists sometimes use the average yearly decrease in mass for estimation purposes. Use the average yearly decrease in your mass of the sample between 0 and 10 to predict the amount of remaining after 40 years. Okay, so what we're going to do is this. We're going to create the average rate of change. So remember, average rate of change is the same as slope. So I want to do a of t, a of 10, minus a of 0, all over 10 minus 0, because those are the years they predicted for us. So we need to type that into our calculator and figure out what we got. So I'm going to put the stuff down here, 100, 1/2 to the 0 over 63. That's 0. That's 100. So that's easy. Oh, no. 0 is easy. That's 100. So now I got to figure out what the other one is. So that's going to be 100 parentheses 0.5. I always use that for half. Raised to the control division 10 over 63. 89 point, and don't round this. Crap, I didn't leave myself room. 89.581 320 707. Anyway, so then what we'll do is we'll take that, we'll subtract 100, and then we'll divide by 10. And we get negative 1.418. So negative 1.4, negative 0.04186 79. So this is the average rate of change from 0 to 10 years. This is so dumb to do this. Okay, so use that number to predict your answer to the nearest tenths place. Hold on, I got a break so I don't lose it. All right, so if we're going to lose this much every year for 40 years, so what we got to do is just take 40 and multiply it by negative 1.041867 and we get, my goodness, times 40. Negative 41.67, negative 41 points, my goodness, 0.67, 4717. So this is how much we're going to lose. What did they actually ask for? To predict the sample. Okay, so now this is careful. I think I almost made a mistake here. The question says to predict the amount of the sample remaining after 40 years, right? So if I lose this much, then what I got to do is say, okay, I started with 100, and then we're going to subtract off this. That means I have I'm subtracting out this. I'm left with 58.3. Now, when I round this to the nearest tenth, so there would be approximately 58 point, come on, stay off my screen, 58.3, what do we start with? This is grams. Grams remaining after 40 years. Is the actual mass of the sample or estimated mass greater after 40 years? Justify your answer. Is the actual mass of the sample or the estimated mass greater after 40? So they're basically saying which one's going to be greater. So let's do this the right way. A of 40 is equal to 100, 1/2 to the 40 over 63. We'll type that in. Parenthesis 0.5, parenthesis, raised to the control division 40 over 63. And we get 64.397. So 64.4. 64.39762 something. 62. So is the actual mass of the sample or the estimated mass greater? The actual mass would be greater than the estimated amount. Now, why is that? This is because A of t is an exponential decay function, which means it loses a lot at the beginning, but as time goes on, the rate of change decreases. In other words, an exponential decay function starts out like this. Start out at 100, and it comes down steep, 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 but as it goes on, its rate of change changes. So an exponential function, the rate of change decreases with time. So that's probably the better way to say it. The rate of change decreases as, so this one assumes a consistent or constant rate of change, you know, and so for those first 10 years, look at that. For the first 10 years, it was pretty steep, but then it just leveled off. So the reason is because it's an exponential function, that rate of change decreases with time. That's the best way to say it. All right, kids, that's it. That's the end of the function. There you go. Goodbye. Hit subscribe. Get those flashcards. They'll be helpful. Get the flashcards.